Hello, Sherry. This is Instructor Johnson again. Wanting to touch base with you in regards to question number 49. We're dealing with quadratic inequality here. We're dealing with values of the function that well, let's read the question. So a company determines that its total profit is given by the function p of x is equal to negative 4x squared plus 760x minus 7,200. The company makes a profit for those non-negative values of x for which p of x is greater than 0. The company loses money for those non-negative values of x for which p of x is less than 0. Find the values of x for which the company makes profit and loses money. So when they talk about, first off, they talk a lot about these non-negative values for x. All they're really saying here is that x has to be greater than or equal to 0. That's what they're referring to when they're referring to non-negative values. And so let's think about this for a second, too, in terms of the context of the problem. We're talking about a company, and we're talking about a model that determines profit based upon some x values. So I will agree that they don't really define what x is going to be equal to. X could be a widget, x could be an iPad, x could be a guitar. X is something that this company produces and then sells, right? And I agree with you that they probably could have defined what they meant by non-negative 0. And what x is what x is supposed to represent in terms of this function p, but that withstanding, we still are able to determine when this company will make profit for non-zero values of x, and when it will actually lose money. So let's go ahead and take a look at that. So for me, the function that is given to me is the following. I'm given that p of x is equal to negative 4x squared plus 760x minus 720. So we know how to find zeros for parabolas. We know that this is going to be a parabola. You would probably tell me it's going to be a parabola that's opening down. The y-intercept is going to be 0, comma, negative 7,020. So we can, just by looking at just the function itself, just by looking at it, we can see that it's going to open down. It's going to have a y-intercept of 0, comma, negative 720. So this gives us a bit of an idea of how this function is going to behave graphically. So if I were to graph this, I'm gonna do my best to actually draw a graph here, or what we can see of a graph. So we have our function here. We know that it's going to intersect. This is my x-axis and this is my y-axis. We know that this function is going to intersect the y-axis at negative 7,200. Or when x is equal to 0, y is going to be negative 7,200. So let's just say that this is the order pair, 0, comma, negative 7,200. Okay. We know that it's going to open down, so that means just as some idea. I don't know if this is going to actually be the graph. This is the potential shape that it may have, but it's going to come from here and it's going to go up, and then it's going to reach some max and then come back down. I don't know whether or not it's going to cross the x-axis here and here. Actually, I'm just giving you the general shape of it. The general shape is just gonna do something like this. We know it's going to open down. It's going to come back up. It's going to go up and come back down, rather. So really what we're looking at is we're interested, when we graph this thing, or if we graph this thing, we're interested in seeing, and remember, this is our profit equation. This is p of x. So one way we could think about it is that we know that anything above this x-axis here, in terms of y, is going to be a positive. and anything below that is going to be a negative. So when we think about profit, we typically like to think about, when we think about when a company's making profit, it's going to be above the x-axis. And when we think about a company actually losing money, not making profit, let's just stick with losing money because we haven't talked about the break-even point. But let's talk about losing money. When we talk about a company losing profit, that's typically, or losing money, that's typically negative. So really what we're looking for is we're looking for these intervals where our graph is losing, and we want to find out where that is and over what interval of x this is taking place over. And on the flip side of that, we also want to find out what values of x is this thing making profit. And of course everything above this line here is to be implied that profit is being made. So I guess the first question is that, okay, let's find, we know what the y-intercept is. The y-intercept is negative, so that's if I don't sell anything, or if the company doesn't sell anything, they're losing money, they're losing $7,200, I don't know, every second, every minute, every hour, every day. They didn't give us that either. But that's kind of where we can go with this problem. So what I would suggest doing is that we know that anything, if we find the x-intercept, then we can determine, if we find the x-intercepts, then we can determine just by plugging in points to the left and to the right of those x-intercepts, over which interval is the company going to be making profit, or which interval the company's going to be actually losing money. So here, what I would suggest doing is just first finding the x-intercept, and we can do this by using our quadratic formula. X is equal to, I'm sorry, let me go ahead and change the color of my ink there. X is equal to minus b plus or minus the square root of b squared minus 4 times a times c, all that divided by 2 times a. Okay, so a for us is going to be equal to negative 4, b for us is going to be equal to 760, and c for us is going to be equal to negative 7,200. So at this point I suggest pulling out our calculators. Okay, so in our calculators we want to calculate what, well, we know what negative b is, right? Negative b is just going to be equal to minus 276. So that's just going to be, or negative 276, so it's minus, I'm sorry, I don't know why I'm saying 276, 760. So negative 760 plus or minus the square root of, well, b for us is equal to, again, 760. So 760 squared is going to be equal to a very large number, 577,600. So 577,600. And then we're going to subtract that, and we're going to subtract from that minus or negative 4 times a negative 4 times a negative 7,200. And so we get, so that's a minus 115,200. So if I take and I subtract those two, so 577,600 minus 115,200, we get, oh, and don't forget to divide this by 2 times negative 4, or that's going to be negative 8. So writing our next line here, I get negative 760 plus or minus the square root of, what did I get, 462,400, all that divided by negative 8. So I don't know if we can take the square root of that number and have it be rational. We'll take a look at that here in a second. So what I'm going to do is I'm going to take the square root of 462,400 to see if that that exists, and it does. So here, when I take the square root of negative take the square root of 462,400. This is the same thing as negative 760 plus or minus. I got 680. All that divided by negative 8. So now we're going to get two solutions out of this. Our first solution, x, let me free up some room here again. Our first solution, x, is going to be equal to negative 760 plus 680 divided by negative 8. And our other x value is going to be equal to, negative 760 minus 680, all that divided by negative 8. So let's calculate these two x values. So just go into your calculator and take negative 760 plus 680 and divide that by negative 8, and you're going to get a positive 10. So this comes out to be a positive 10. As for our other number, I get negative 760 minus 680, and I'm going to divide that by a negative 8, and I get a positive 180, sorry. So this is where our intercepts are going to be at 10 and negative 8. So let's go back. I know we talked. Let's go back to our earlier graph here. So here's our earlier graph that we kind of just put together here. We found this value here. This is x is equal to 10. And we found this value here. Remember, these are the x-intercepts, right, where it crosses the x-axis. This is x is equal to 180. Okay, so we found those 2 points. The general shape is what the general shape is. It opens down. We know that the y-intercept is at 0, negative 7,200, and we found the x-intercepts to be equal to x is equal to 10, and x is equal to 180. So let's go back and take a look at what they were asking us. They were asking us to find the values of x for which the company makes a profit and loses money. So here, at these points, earlier I alluded to what I called the break-even point. This is the point where the company's neither making money or the company's neither losing money. They're just breaking even, right? So what we found here with x is equal to 180 and x is equal to 10 are actually the break-even points. These are the points where the company doesn't lose or make any money. But as we look at the graph, and we say that all values greater than 10, all production values greater than 10 but less than 180, so that's this space in between here, actually produces a profit for us. So we would say that profit takes place over the interval 10 all the way up to 180. Now notice how I'm using parentheses here. It kind of almost looks like I'm listing an order pair here, but really what I'm listing is a domain that satisfies the criteria for profit using interval notation. So we know, and so the parentheses there just implies that we're not going to include the endpoints. So if we look at loss, we would see that anything, so x less than 10 or x less than or greater than, let me just correct that. For x less than 10 or x greater than 180, which is right below here, we see that the company's actually getting a loss there. They're losing money. So this one's a little bit more difficult to define in interval notation. I suppose if I had to define it in interval notation, we know it would be from 0 to 10, not including 10. But the other side is a little bit more curious for me in defining this in terms of interval notation, because theoretically they can make an infinite amount of products. And we all know that a company can't make an infinite number of product at some point, but that's just impossible. So I would actually stick with using this notation, just because they didn't define the maximum number in which the company can produce in terms of X items. So, interesting question, though. I'm a little curious about this question in general. In any case, Sherry, let me know what you think, and if you have any other questions, please don't hesitate to contact me.